First of all, what is a complete system? A complete system for the DMV2000 is the controller itself. It will be delivered with a mouse. You have to add a camera and a camera cable, of course. You have to select the lens, what is suitable for your application and connectable to your camera. Then you need to have a light source, of course, if possible with dimmer, because then you can play around with the light itself. And you need a screen what you have to connect to the DMV2000 that you can see what you are doing at that moment. In a standard package, if you order the DMV2000, you find the controller. We have two different versions, one for 2 cameras, one for 4 cameras, and the mouse itself. Also included is a small SD card. Optional, of course, the camera. It's depending on which camera you want to use, 0.3, 2 megapixel, 4, 5 or 12 megapixel. The lens, the suitable lens for that type of camera, of course, because the lens for a 2 megapixel camera is different than for a 0.3 megapixel camera. And we can help you also with a LED light and a power source for that light. That is depending on your application, what you want to do, of course. Therefore, you can use the type of light. These are the cameras what are available for the DMV2000. That is 0.3, 2, 4, 5, 12 megapixel in grayscale, but also in color. Depending on the amount of pixels you have, a chip size and size, and also the pixel size is different for each type of camera. How to select the right components? It's also always depending on what you want to check and what kind of accuracy you want to have with your system. And finally, of course. And also, how many cameras do you want to use in your application? Because, of course, you cannot do everything with only one camera. Sometimes it's easier to use 2 cameras or 3 cameras. We have 2 types of controllers. One is with 2 camera connectable and one is with 4 cameras connectable. This is how our DMV2000 system looks like. Of course, at the left upper corner, you have the power supply input, 24-volt power supply. Below that one, you have the I/O, the interface, the inputs and outputs. And below that one, you have the RS-232 connection. That is usable, for example, to connect the DMV2000 to a PLC PC. In the middle, we have at the top the micro SD card slot. Below that one, we have an Ethernet connection possibility. There's also a possibility for PLC PC connection. Then we have the USB 2.0 connection. That is for the mouse itself. Below that one, it's the HDMI. There we can connect a screen, or you can use the VGA input at the bottom. And we have also there the RS-485 connection. RS-232, 485 and Ethernet outputs are usable for PC or PLC connection. At the right side, you have the connection possibility for the camera with the camera link cables. On the picture, you see the possibility for connecting 4 cameras. If you have only the one with the 2 cameras, then only the top slot is available. At the side, at point 14, there you have, there's always the battery available. After 5-6 years, you have to replace it with another one. And slot 15 is not used at this moment, but that will be for the future to expand to other controllers. In numbers, of course, all the inputs and outputs, what I just explained, what are available on the front. General specifications, 24 volt, operation voltage between 90 and 110%. That means 10% above and below 24 volt. Power consumption is, of course, depending on the amount of cameras what you have connected to the system. Operating temperature is maximum 45 degrees Celsius. And the battery lifespan is roughly 5 years or more. It's not exactly to say, of course. Type of cameras that can be connected is only the camera what we can provide for the DMV2000 system. It's a camera based on camera link. You cannot use another camera with camera link because we have made special connections to the camera for that one. And we have color and grayscale cameras. The different types of resolutions, as already explained. 2 types of controller systems. The normal lens mount is C mount. Only for the 12 megapixel camera we have F mount camera lenses. Internally, we have the possibility to save more than 1,000 programs. With the memory card, depending on the size of the memory card, SD card, you can go up to 9,999. So possibilities, projects enough. We have different types of region of interest, of course, rectangular, circle, polygon, ellipse, circle, arc, rotation, angle. I will explain that later. We have also different types of masks. I will also explain what a mask is and what you can do with that. And you have the possibility for 8 different types of masks in each window. Pre-processing, different types of pre-processing. We'll also explain where you can use it and how you can use it and when you have to use it sometimes. And you can switch in run mode, but also in edit mode. Calculation processing. There's also a possibility to add a complete calculation inside. We will not do that today, but I will show you where it is and how the screen looks like. We can only connect one type of display that has a full HD display 1920 at 1080, and you can connect via VGA or HDMI. Memory card is the micro SD card, is delivered with the controller, and we can only connect directly with the mouse, what is delivered with the controller. Okay, the second thing, we have now checked what kind of controller we want to have. We have 2 possibilities for connecting 2 cameras or 4 cameras. The next step is, of course, what kind of camera I want to use, what kind of accuracy I need to have. This is depending on what you want to do. If you want to do measuring, then you need, of course, a higher accuracy than only when you want to check on availability of some items or the position of some items. So depending on what you want to do, you have to calculate, of course, also your accuracy, but you have to use a different type of camera. So the third thing, what you have to check, of course, how large is my field of view? What kind of items I want to check, and this has influence on the accuracy, of course, and also on the type of lens. The third thing, what is important, is the working distance. That means the distance between the camera and your object itself. That is the third item what has influence on the accuracy. Here you see a small overview how to calculate with the formula. In this example, we use a 0.3 megapixel camera. That is a 1/3 inch camera and has the amount of pixels: horizontal 640, vertical 480, and a pixel size of 7.4 micrometer. If we use a lens with a focus distance of 8 millimeter and a working distance of 700 millimeter, then you can reach a field of view of 480 multiplied by 360 millimeter. If you fill that in your formula, then the field of view will get out of this one. The small f accent is, of course, the focus, and the B is the size of the chip inside of the camera. Some examples how to calculate. Of course, when I have an SD card, for example, it has the size of vertical 32 millimeter, horizontal 24 millimeter. So when I want to do something on this card, my minimum field of view will be roughly 40 multiplied by 30 millimeter. At the size, at the edge of the lens, you have always distortion, so the field of view must be a little bit smaller than your view of your camera itself. In this case, we choose for a field of view of 100 multiplied by 50 millimeter. And we have a fixed working distance. That means my camera is on a fixed distance of 200 millimeter from my object. If I fill it in, then I can calculate directly what my focus of my lens has to be. So in this case, I have the value of 23.52. So the nearby focus lens is 25 in this case. So I have to use a lens of 25 millimeter to reach this field of view on this working distance. And if you calculate back with this 25 millimeter focus, then you get the exact field of view. The optical resolution, what you can reach in this case with a 2 megapixel camera, is of course the size 93.8 millimeter divided by 2048 pixels, because that is what you have horizontal with a 2 megapixel camera. That means your accuracy is 45.8 micrometer for each pixel. This is the optical resolution. In a real application, you cannot detect on 1 pixel. So the minimum what you can reach is 3 to 5 pixels accuracy. That means you have to multiply this minimum with 3. I do the same with, for example, a 2 megapixel camera and I use a focus lens with 35 millimeter, and I want to reach a field of view of 40 multiplied by 30 millimeter. So the question is, what is my working distance in that case? This chip size is 11.26 millimeter multiplied by 5.98 millimeter. The working distance is, in that case, you can calculate that as directly 170 millimeter. And with that one, you can reach a field of view of 56 multiplied by 30 millimeter. And your resolution is much higher. This has always to do with your size of your field of view. The bigger your field of view, the less accuracy you will have. If you don't want to calculate, in our user manual, we have already done some calculations for you. You see here in the left column the field of view, what you can reach with a lens with a 5 millimeter focus or 25 millimeter focus, and then you have directly the distance in millimeters. The R, what is mentioned here, sometimes there is also mentioned that you have to use a ring between the lens and the camera, and with that ring you can change your focus between your focus of your lens in that case. If you have, for example, here a ring of 2 millimeter, that means in combination with a focus lens of 12 millimeter, we have a distance of 40 millimeter. 40 millimeter is not a standard in the lens, so that's the reason they can use rings in that case.